So we're getting close to the end of our conference, but we save the best to last. And there's a really cool session coming up on identity theft is not a joke. Azure. I love the title. With us is Karl Fosaaen, the Vice President of Research, Netspi. And the one thing that I just want to highlight on Karl's bio that honestly I hadn't seen before, but I'm going to get it, is that he co-authored the book Penetration Testing Azure for Ethical Hackers. Sounds like a good read. And what I've seen from the description of the session, it's pretty much a nice summary of a lot of the things that we might have heard before, but with a different spin on it. So looking forward to your session, Karl.
Thank you. All right. Hopefully everybody can hear me okay here. Thank you all for making it to the end of the day here and joining us. We'll get started. So that was a really good background here, but a little extra information about myself here. Currently the VP of Research, or a VP of Research. I have a counterpart, Scott, and the two of us do a lot of research and development at Netspi, coming up with new products, services, those kind of things. So that's really my day-to-day. But for the last 14 years now that I've been at Netspi, I've done a little bit of everything: pen testing, managing teams, that kind of stuff. So I am coming at this from more of a pen testing background. I know that we have a fair number of defenders here that are actually dealing with the effects of some of the attacks that we'll talk about here today. But I'm going to try and highlight some potential detections that you might have for some of the attacks that we're going to talk about today. You can find some of the tools that we're going to talk about out on the Netspi GitHub. We'll talk about Microburst, which I created 6 years ago, something like that, but that houses a lot of the Azure pen testing tools that we utilize, along with Funko Pop, which is something for attacking Azure function apps, but we'll talk about that in a little bit. And yeah, in my spare time, I like to fly airplanes. So if anybody else is a pilot and wants to chat about stuff, let me know. So before we get into kind of my contributions to the research that we'll talk about here, wanted to highlight some other folks that have done research in this space. If you're visiting this later or taking a look at the slides after the fact, all of the links in the slides here should go somewhere. But definitely recommend taking a look at these other blog posts that are out there. They dive a little bit deeper into some of the concepts that we're going to talk about, might give a little clearer instruction outside of what we have in the slides here. So a quick overview of what we're going to cover in the presentation here. For those that are not familiar with managed identities, we're going to give a quick overview of what managed identities are and how they function within the Azure ecosystem. We'll explain how managed identities can be abused with certain services within Azure, and talk about a specific service or a specific resource type of deployment scripts and how that can actually enable us to abuse user-assigned managed identities a little bit easier within Azure. And once we've gone through how we can get access to all of these tokens, we'll talk about sources of certificates that are associated with managed identities, and then show you where you can use those tokens and certificates and kind of what you can do with that at that point. To start things off, managed identities are a method for authenticating as a resource to Entra ID. So let's say that you're a virtual machine and you want to connect to Entra ID to get access to something, a key vault, a storage account, something that's in Azure. You need to be able to read the data out of that or access specific APIs, anything like that. You need a method to authenticate to Entra ID. And you don't really want to store any credentials in clear text or keep anything on the virtual machine itself, because that can be taken off the virtual machine and used elsewhere. So we have the managed identity service. The managed identities can be either system assigned, which are tied to the single resource itself. So our virtual machine with the fancy mustache and hat here, we'll pretend that that has a system assigned managed identity. That managed identity will never leave that virtual machine. It is tied to that specific resource, that specific virtual machine, and only it can generate tokens as itself. The user-assigned managed identities are a subscription-level resource that can be applied to different resources in Azure. So let's say you had 5 of those virtual machines that are up there. They can all share a user-assigned managed identity in the Azure subscription so that they can all act with the same permissions. This is really handy for things like scaling, or if you've got every single virtual machine needs to access the same key vault, you can share a user-assigned managed identity and then generate tokens out of that. It simplifies a lot of stuff. You just have one identity at that point, and then you configure permissions around that. Makes life a little bit easier. But all that being said, with managed identities, the core idea is that you authenticate to some kind of service. We'll talk about the different kind of IMDS types of services that we can authenticate to as the managed identity and get tokens for. But you get that token, and then you utilize it to access a resource, and that's about it. There are a wide variety of services that support managed identities within Azure. However, we're just going to focus on the ones that readily allow us to get tokens out of the service. There are specific services where you can use managed identity to get access to something, but we have no easy way to get that token that the managed identity is utilizing. We have no easy way to get that out of the resource, so we're not really going to highlight those today. So I did talk about kind of the token side of things. In order to get the tokens for the managed identity, the managed identity has a service principal associated with it. So going back to our virtual machine here, when you add a managed identity to that, in Enter ID, you'll see a service principal, primarily the enterprise app side of things for the managed identities. That's the easiest way to see that up in the Azure portal. But if you're using things like the REST APIs or the AZ PowerShell commandlets, you can actually see that there are credentials associated with the service principal. So in our screenshot here, we can see that we've got 3 different certificates associated with the managed identity that we're utilizing. It's kind of an interesting thing that they kind of keep away from users. You can't go to the app registrations in the Azure portal and pull all of this up, but there are definitely credentials that exist for these managed identities. Now, when an IMDS service spins up so that you can get tokens out of that, that utilizes these certificates in the backend to authenticate up to Enter ID to then issue tokens for you. We'll go through that process in the next slide here. But the certificates that are used here typically have a 3-month expiration on them. There's a little bit of math between how long the certs are valid and how often they get rotated, and it kind of changes between the different types of managed identities, but we'll just call them 3-month expirations in general. And the most important part about this slide is that users are never supposed to get access to those managed identity certificates. The whole point of having a managed identity is to not have access to the actual credentials, and the resource itself will give you a temporary credential. So keep that in mind as we talk at the end about a couple of different sources where we've been able to access these certificates, either in the past or currently. So the other kind of secondary credential thing that we'll talk about here real quick is for user-assigned managed identities, you have something called a federated credential that you can add. And this is for authenticating as that user-assigned managed identity outside of some of the Azure resources. So you can utilize something like a GitHub action with a user-assigned managed identity and add that federated credential there to then take actions in Azure. This is convenient for any kind of actions that you might want to take in GitHub, something like that. But there's been some really interesting research from Roger and Dirkjan. Both have separate blog posts. We have them linked at the start of the slides here. But they both were playing around with federated credentials kind of around the same time. And the primary thing is that you can add these federated credentials to the user-assigned managed identity and potentially persist for quite a long time as that user-assigned managed identity outside of the resources it's associated with. So definitely something to look into and something to keep an eye out for. If you have user-assigned managed identities, take a look to see if they have any federated credentials associated with them. We've found some very interesting things in some client environments in the past. So as I talked about with the credential mechanism, the IMDS or Instance Metadata Service is something that people that maybe are a little more familiar with other cloud providers, namely AWS, might be more familiar with IMDS. Azure has the exact same thing for virtual machines as AWS has for EC2 instances. You have an HTTP server that's sitting there that you make web requests out to. It gives you temporary tokens. There's some definite differences between the different cloud providers. Namely, IMDS v1 for AWS didn't require any special headers, so you had things like SSRF that were kind of a big problem. Azure actually requires specific headers. We'll see those coming up here in a minute. But with that IMDS service, there's also kind of sidecar services for some of the other resources that at the end of the day, it's a web request that you make to get a token. You give it a scope that you want a token for, so something like management, graph, vault, a number of different scopes that you need temporary credentials for. You make a HTTP request out, you get your token back, and then you can use your token wherever you need to use that. In addition to that IMDS service, you are able to authenticate with things like the AZ PowerShell commandlets or the AZ CLI using the identity flag. So if anybody is on say a virtual machine that has either of those tools installed, you can just authenticate as that managed identity with those tools. It's really convenient for taking actions, or if you're a pen tester, it's a nice way to be able to get access to managed identity a little bit more persistently. So we'll go kind of service by service here, and for each service that we talk about, we'll talk about the initial access method that you need in order to start trying to generate tokens for the specific service. And give you a couple examples of how that token might be generated. These are hopefully good indicators for any defenders that are in the crowd here that want to see what commands are being run and kind of what that process looks like from a token generation perspective. We'll also try to highlight any tooling that's out there so you can keep an eye out for any tools that might hit your system, or maybe you can use those tools to replicate these same kind of results to try and tune those detections for yourself. And all of our examples are going to focus on system-assigned managed identities. The user-assigned managed identities are exactly the same process. However, with most of these, you actually have to specify the client ID of the user-assigned managed identity that you want to authenticate it with. It's just easier to save some space on the slides here. So just kind of keep that in mind as we go through this. So first up, we're going to talk about virtual machines. We already gave a couple of basic examples here as we were getting started, but as an attacker, typically what I would do as a first step once I've got command execution on a virtual machine is to take a look and see if there's a managed identity attached to that virtual machine. Normally, situational awareness-wise, we've got a pretty good idea if we're in Azure, and if we've got command execution on a virtual machine, one of the first things we're going to do is try to get access to additional things outside of the virtual machine itself. So this can be done through, say, command injection in an application, direct access through authenticated protocols, RDP, SSH, anything like that. Additionally, execution with Azure credentials. If you have the ability to run commands through, say, VM run command on Azure, you can just directly run commands on the virtual machines themselves. As I mentioned, this does require a specific header. This is the metadata true header. And as I mentioned with SSRF, or server-side request forgery, oftentimes you don't have control over those headers. So it is a benefit here that Azure's had for quite a long time, requiring that specific header to prevent things like SSRF from exploiting the IMDS here. With Windows and Linux, we have a couple example commands here. The core thing to really remember is that, there's our laser. The 169.254, 169.254, that is your IMDS endpoint. That's where you're going to be making those requests for the specific scope that you want to get the token for. So pretty simple. From an automated tooling perspective, we've got some tooling in microburst that allows you to run commands on virtual machines kind of at scale. So attackers might be running multiple commands against multiple different virtual machines in order to extract any managed identity tokens that they might want to get access to. And this is also inclusive of virtual machine scale sets. For those that are not familiar with the VMSS service, it's like virtual machines. It's just scalable and they just have nodes. So Very similar there. Next up, we have app services. Virtual machines is very simply named. It's a virtual machine. App services is a little bit more nebulous. So if you're not familiar with the app services service, that service is a way to host web applications up in Azure. So this is inclusive of function apps as well. That's really more of the API-centric offering for the platform as a service app hosting that you have up in Azure. But either way, with app services, our initial access method is typically going to be some kind of command execution, much like virtual machines, done through command injection, or conveniently, Azure gives us multiple different ways that we can run commands directly in the containers for app services. You have the SSH or console menu directly in the Azure portal. There's also the SCM interface, which is a management interface for app services. I put it in here. It's something that I've talked about in the past, but if you have access to the storage account associated with the function app, you can actually overwrite files in there and take over function apps, but that's a whole other presentation for another time. But hypothetically, you could take over the function app and execute commands there to then generate tokens. I noted at the bottom here the Funko Pop repo. That's the tool that we wrote to automate this process. But either way, with app services, you do require a special header here. This helps prevent against SSRF. It's either going to be the secret or X identity header, and the values for those are stored in environmental variables in the container. So you just reference those environmental variables and then feed that in as a header and make that request out to the MSI endpoint. There is an interesting bug that we'll talk about in automation accounts that relates to this, but we'll get to that when we get to automation accounts. Let's see. Okay, so that covers app services. Next up, we have the ACR service, or Azure Container Registry Service. This is the service that you hold your containers in. You make an ACR repo and push all of your containers up there. Really handy service. I like to make use of it for storing a lot of my container images, but it also allows users to execute tasks for the containers themselves. So let's say that you're building up a specific container, you want to apply updates, push new code to it, anything like that. You can configure tasks to automate that process. With the task execution, you can feed in managed identities, either user-assigned managed identities or have associated system-assigned managed identities with the ACR repo. And either of those can be attached to a specific task and then run in that context. So with this one, what we would do as an attacker, we would create the malicious task YAML here, where we do an AZ login on the CLI and do AZ account get access token. Very simple. We authenticate as the managed identity, and we just get an access token using the AZ CLI. It's really convenient, really simple. We push this malicious task out to the ACR. When we push that out to the ACR and then run it, we can see the output in the window over here. We have everything kind of blocked out here to get rid of the token. But when we run that in the ACR, we're able to extract out the token. The tooling that we have around this, it very, very briefly stores that token up in the ACR task. So if you are concerned about token exposure in your subscription, I'd say maybe don't run this, but it's a very, very brief exposure. So just something to think about. But general idea here is we output the token, we grab the token, we delete the task and clean everything up. And outside of activity logs of a new task was created and run and deleted, it's a pretty quiet way to generate those tokens for that ACR. As I mentioned, we do have a tool that automates this whole process. I mentioned Andy on the previous research slides here, but Andy Robbins did kind of the initial research that got me interested in this. And the tool that we wrote within Microburst is me trying to replicate some of his initial research here, getting frustrated with it, and then just automating a whole tool to automate the whole thing. So shout out to Andy for kind of helping with the tooling on that, I guess. Next up, we have automation accounts. So I hinted at automation accounts earlier. The X identity header is kind of the tie-in with app services. We'll talk about how that wasn't always there in a second here. But automation accounts are a way to run code or serverless code running in Azure. I'm a huge fan of automation accounts. They do a lot of the processing for me for all sorts of different things. It's just so much easier to feed a PowerShell or Python script off to an automation account to handle stuff for me in the background. So I make heavy use of these in my own subscriptions, but definitely a very convenient tool to utilize in Azure. So with the automation accounts, you have runbooks. That's where your code is run. It's either PowerShell or Python, as I mentioned. And as an attacker, if we have permissions to write that runbook code, we have the ability to then tell the runbook, hey, while you're here, go ahead and authenticate as the managed identity associated with the automation account. The attacker would typically create or edit an existing runbook, tell it to authenticate as the managed identity, and then get it to output the token out to either the test pane or out to the output of the run of the automation account. If you're going to do this manually and play around with this yourself and are concerned about token exposure, keep in mind that if you run this either as a job or in the test pane, there's a good chance that anybody with reader permissions to read the automation account can also see that token. We pretty regularly see tokens being output to automation account job output. So this also applies to the test pane. So if you're going to output stuff to the test pane, make sure you either delete the runbook or run it a couple of times without outputting anything to the test pane, because that could potentially expose a token. When we automated this whole action in the microburst get AZ passwords tool, we actually encrypt all of that data. So all of that output data that you see there is actually encrypted. The key's not going to be shown there, so you don't have to worry about that potential exposure there. So the nice things about the automation account runbooks is everything's really integrated with the AZ PowerShell modules. It makes it really easy to just utilize everything that exists there. However, it's better to actually make the local HTTP requests using that X identity header that I had mentioned before, because I've run into issues with the PowerShell modules before and trying to automate this for kind of portability across multiple different environments. The AZ PowerShell commandlets don't always stay up to date or work properly in other environments. So if you're going to play around with this, I'd say it's good to make the calls directly to the sidecar service here to get the tokens. With that X identity header, automation accounts kind of had some issues with how the managed identities were being utilized in the containers themselves within automation accounts. Around about the time that they were starting to push people away from using what was previously called run as accounts within automation accounts. That was a service principle that was associated with the automation account. Not supported anymore. You can kind of make them work sort of with existing things in automation accounts, but that's not really for this presentation. But when the managed identity service was brought over to automation accounts, it initially did not require any additional headers. So I can't remember who it was. I have it listed in the references at the beginning. But the auto warp vulnerability was identified where as you're running code in the runbook, they were able to identify that other high number ports that were running the sidecar IMDS service within automation accounts, they would just grant tokens. So if you were able to enumerate other high numbered open ports in the automation account container, there was poor separation between the different containers in that environment, and you could actually get tokens for other tenants' managed identities. So it was a pretty bad exposure. I think it was a month or so, maybe 2 months after the managed identity service was brought over to automation accounts. So it was a pretty quick turnaround. But yeah, definitely look up the auto warp vulnerability. That was an interesting find. The last thing that I'll call out about automation accounts here is there's something called a hybrid worker in the concept of automation accounts. So If you do not have enough horsepower or compute power, whatever you want to call it, for the container in automation accounts by default, you can actually enroll a hybrid worker. It's either a virtual machine or an Azure Arc machine. We'll talk about Arc later. But either one of those you can enroll as a hybrid worker because it's got more memory, it's got more disk space, it's got better compute power, anything like that. And you can utilize those to run your serverless code technically on a server. But that uses something called the Job Runtime Data Service, the JRDS. And when that hybrid worker goes to take the code runbook to run, it calls back up to the automation account with its own system-assigned managed identity. And you can use that token on the virtual machine or Arc machine itself, talk to the JRDS, and actually get a managed identity token for the automation account. So it's a weird kind of circular thing of if you're able to get access to the hybrid worker, you can actually escalate up to the system-assigned or user-assigned managed identity for the automation account. So kind of an interesting pivot path there. As I mentioned, we can utilize get AZ passwords with the automation account flag for this to extract out any available managed identity tokens for automation accounts. Pretty handy way, and it's, I'd say, the safest way to get managed identity tokens out of automation accounts. So one of the last services that we'll cover here is Logic Apps. For those that are not familiar with Logic Apps, this is a low-code, no-code solution within Azure to help build out workflows, automations, anything like that. I'm personally a fan of them because it's pretty easy to create different triggers to start different actions, helps automate a lot of different processes. Any attackers that do have the ability to modify existing Logic Apps, because typically you're going to be going after a specific existing Logic App versus creating your own and assigning managed identities and that kind of situation. The attacker would initially need to get access to the Logic App and have the ability to write it. But what they can do is create a parallel execution path so that when that Logic App runs, you follow two different paths at once and do two different executions. And on that secondary execution, you can go ahead and make an HTTP request outbound. So in the example that we have here, we're just going out to netspi.com and going to token listener. And when we make that outbound HTTP request in the workflow here, we can tell the HTTP request to go ahead and use the managed identity, and you pick the managed identity that you want to use, and select your audience or your scope that you're generating the token for. I think in this case, we've got key vaults. And just send that along with your HTTP request. So this is really convenient as an attacker because we can just say, all right, go ahead and add this to my code, save it. Next time that this Logic App runs, just go ahead and send me a management token on some HTTP endpoint that I control. Now, the intended functionality of this is to be able to make requests out to vault.azure.com. If you want to basically run your own REST API code to call out to the different REST APIs, this is the intent of it. However, they don't restrict the endpoint to just Microsoft endpoints. You can actually just send this out to anywhere on the internet. So convenient for us as attackers, but definitely something you want to keep an eye on from your Logic Apps perspective. Normally what we see is those are set it and forget it. You build up your automation and don't change the Logic App. So definitely build some detections around anybody that's modifying Logic Apps because this is an easy way to abuse that. In addition to that, it's not necessarily a managed identity specific thing, but there are API connectors that you utilize with Logic Apps to help facilitate these connections. If somebody does have permissions to modify these Logic Apps, they can abuse those connections as well, which that's kind of dangerous in its own way there. One other kind of small thing to note on here, we talked about the Funko Pop tool that we wrote. For Logic Apps that utilize the standard plan, there's consumption, which is kind of your base level utilization of the service, or the standard plan, which is the more kind of persistent usage and more dedicated plan. The standard plan is actually supported by a function app, and you can see the storage account for that function app that is the Logic app, effectively the storage account for the Logic app, I guess. And if you have contributor level permissions, the ability to modify files in that storage account. You can actually attack logic apps that way. Another potential way that somebody could take over a logic app and get managed identity credentials out of that. Come on, there we go. All right, so this is technically the last of the services that we'd talk about potentially abusing within Azure to get credentials, but this is deployment scripts. And deployment scripts are kind of this weird gray area of like deployment templates within Azure, but also it's a resource that you can create, but oftentimes we don't see them sticking around very long, so they kind of live in this interesting space within Azure. And deployment scripts are really just a way to programmatically modify resources or run specific Azure commands while you're doing a deployment. So let's say that we want to create a virtual machine and configure it a specific way as we're deploying it. Instead of using something like a custom script extension or some other kind of code that would run on the system as part of the build process, you can actually automate all of this with a deployment script. The nice thing about deployment scripts is you can attach user-assigned managed identities to them. The other nice thing about deployment scripts is you don't really have to use them with anything else. You can just create a deployment script that is a deployment script. So it's a great way to run code as a user-assigned managed identity in an Azure subscription. I have Roger on here with Project Meow. That was kind of the original research around this. I was really inspired by this because this is probably the easiest way to take over a user-assigned managed identity. As I mentioned before, these are subscription level resources, so if you have the right permissions in the subscription to assign a user-assigned managed identity that might be shared with other resources in the subscription, you can just create this deployment script, temporarily get tokens for the user-assigned managed identity, clean up everything that you're doing, and it's like you were never there. Now, there are logs that will be there, an activity log, and there's a number of different sources that you can use to detect this. But from an attacker's perspective, I don't have to spin up any real resources. It's not like I'm spinning up a virtual machine, attaching the user-assigned managed identity, logging into it, generating tokens. This can all be run very quickly. Deployment scripts execute within probably 3 to 5 minutes. And it's a very quick way to temporarily generate a user-assigned managed identity token that we can then take and utilize elsewhere. Now, persistence-wise, those tokens are only good for, I think, 5 minutes, something like that. So it's a pretty quick turnaround every time you have to use one of these, but it is pretty convenient. All right, I think I covered everything on that slide here. So inspired by that research that Roger did, we automated this whole attack in microburst. We created invoke AZ UA deployment script. Probably not my best naming effort here, but it's a nice handy way to utilize the PowerShell modules to identify any potentially abusable user-assigned managed identities in the subscriptions that you have access to. So when you load up the function from microburst and go ahead and run that, that will use the out grid view function within PowerShell to give you a nice list of the available user-assigned managed identities that you can potentially assign to a deployment script and take over. You select the identity that you want to attack. That will go ahead and create the deployment script for you. That's also supported by a storage account and container instance, but all of those get deleted when you delete the deployment script. And really all this does is it just spins up the deployment. It goes ahead and gets the token for you. You select whatever scope that you want, and now you have your temporary token. Additionally, if you do want to run commands as that user-assigned managed identity, you can feed additional commands into that to then act as that user-assigned managed identity instead of just generating tokens for that. But that's kind of a secondary function of this. So kind of the last section that we'll call it here is finding managed identity certificates. So we just talked about all of the different ways that you can potentially attack different Azure services to create tokens or generate tokens for managed identities. Next up, we'll talk about where we can find these certificates that support these managed identities. One of these options is fixed. One is still kind of available to make use of. We'll talk about that in a second. The first one we're going to talk about is the fixed one. So we talked about function apps, their APIs as a service, and tied to the overall app services part of Azure. And with that, this is a containerized application. So it's a container that spins up, it hosts your web application, and it is a really convenient way to run applications. I make use of function apps all the time. But if you're utilizing the Linux containers, this is still kind of a path that you can get access to some stuff. The Linux containers utilize a container start context, which is passed in through a SAS tokened URL. Now that is a lot of stuff to unpack here. Basically, the container configuration is stored up on an Azure storage account that's controlled by Microsoft. And when you pull down that container configuration as part of the boot process for the container, all of that gets decrypted in the container and then applied to basically run the code that you need, right? So as an attacker, if we get command execution in the container for the function app, we then have the ability to decrypt this SAS context URI, or the startup config. And once we decrypt the startup config, we can get access to things like the source code files, which technically you'd have access to if you already had command execution anyways, but you can download them in zip format. Makes it a little bit easier to pull them off-site somewhere. In addition to that, the function app secrets. Function apps are technically oftentimes restricted authorization or authentication-wise by app secrets that are utilized for that. You can get those in clear text out of this decrypted SAS context. So that's kind of convenient to have. In addition to that, if you get the master key or the master secret out of that, it does allow you to overwrite the function app as well. So that's a nice thing for persistence. But the important part, and the thing that's most pertinent to this, is the MSI specialization payload. Now this is double encrypted now. If you were to run this same attack now, you would just get some encrypted blob data, and you can't decrypt that. The actual key for that is stored on Microsoft side, so it's all protected now. But as of about a year ago, they pushed the update and fixed everything. Prior to that, what you could do is go through this whole decryption process and take a look at that MSI specialization payload. That actually contained the PFX file for the managed identity. And this is how that managed identity certificate was making it to the sidecar IMDS service on the function app. So it came in through that start context, it got applied, and basically told the container, go ahead and use this to authenticate as that managed identity. And this worked for both user-assigned and system-assigned managed identities for the function app. So, well, we didn't really get to use it very much because we reported it to MSRC and they fixed it. It would have been a convenient way to persist as any of those managed identities for a long time. More recently, though, I started poking around with the Azure Arc service. For those that are not familiar with this, the Arc service is a way to bridge the gap between other clouds, on-prem systems, systems that are not in Azure, into Azure. So let's say you've got a virtual machine that's running on-prem and you want that to be able to access Azure resources. You can make use of the Azure Arc service to manage that and enroll that up in Azure to do things like hybrid workers for automation accounts, or use it to get a managed identity that can then talk to Azure to then get access to specific resources. Very convenient. We see it utilized in a lot of places that are partway through their migration up to the cloud. Maybe you've got some systems that are on-prem that need to talk to the cloud. This is a great service to do that. But how it makes those connections is it utilizes a system-assigned managed identity to talk to the Azure service. Well, if you've got a virtual machine that is not in Azure, it doesn't have access to the Azure Service Fabric, so it really doesn't have a way of having a managed identity. So to solve this, Microsoft put the certificates for the associated system-assigned managed identities onto the systems themselves. We have the paths for them up on the slide here, and as a local administrator, you can read those files and then have persistent access to the managed identity for that specific system. So we'll say that we have a Linux virtual machine that's on-prem. You get root on that Linux machine, you now have access to a PFX file that you can now act as that system-assigned managed identity outside of the resource. This technically breaks the fundamental usage of system-assigned managed identities in Azure. But having talked to the Arc team about this, Architecturally, there's not a lot of other ways around this. In order to authenticate up to Azure, you need some kind of secret, something that you can use to authenticate yourself. And this is kind of the best option for it. It allows lots of other things that you would utilize within kind of the Azure fabric. So I get the decision they made, but in their own documentation, they actually recommend that you assign access to the system assigned managed identities in Azure RBAC so that these system assigned managed identities can access things. And this is going to give persistent access to an attacker that escalates on the system. So it's this weird chicken and egg kind of problem, but yeah, we've had some nice discussions with the ARC team about this to try and figure out best path forward. So since this is something that's kind of a can't fix, won't fix kind of situation, we did automate the extraction of all of these ARC certificates. So I try not to make everybody's identity jobs harder, but I'm a pen tester by practice and trying to enable our team to best persist and get access and escalate. We wrote a tool that identifies all of the ARC servers within an Azure subscription that you might have access to and automates that whole process of running commands on the ARC servers. They have a built-in run command feature, which conveniently lets us just get the content or cat out the PFX files themselves, extract them back to us, write them out to files, and then clean up after ourselves. So we automated that whole process. It's part of the microburst toolkit, and check that out if you want to replicate this attack. Definitely something to look out for if anybody's running commands through the run command deployments on your ARC systems. Definitely something you want to keep an eye on. So this is just kind of the MSRC response. We publicly disclosed this back at the DEF CON Cloud Village earlier this year here. Like I said, discussions with them are a little bit ongoing, but it does seem like they're looking to come up with different solutions for this. So hopefully we have some developments in the future for this. But like I said, this is kind of an architecture decision that was made a while ago. So now that we have access to token certificates, we did talk about this a little bit, but there's plenty of automated tools out there that allow you to authenticate with either the tokens or the certificates themselves. At the end of the day, a managed identity is just a service principal in Entra ID. So if you have access to the certificate for it, you can just authenticate like you would any other service principal. So now that we have that access, all sorts of different tools, we can dump out information about Entra ID, about specific subscriptions, anything like that. But that's typically what attackers are going to do. They get access to the token, they want to see what they have access to, and then start getting further access into other identities, other resources, anything like that. So just a couple of conclusions here as we wrapped up. Managed identities are great. They're better than clear text credentials, but they're not without their own flaws. There's definitely some risks associated with them depending on how you're utilizing them and which specific services you're utilizing. And finally, if you want to persist as a managed identity, make use of an ARC system. So that's all I got. Thank you.
Way to go. We got some time for some questions and answers, and I actually have one that sort of scared me just now with the ARC service and the ease of extracting credentials. And maybe it's known or not known, but the Windows Server 2025 hot patching feature requires that you basically integrate the service in ARC to do hot patching. Hot patching itself is actually quite attractive for, well, many. Sort of online patching and memory patching, whatnot. Yeah, at least for critical workloads, that's what customers might want to use them for. How do you see that as a risk?
Potentially. So one of the things that kind of led to us being able to publicly disclose this was Microsoft made it clear that this is kind of a shared responsibility model problem. So if you're adding permissions or RBAC roles, anything like that, to that managed identity, it's kind of your responsibility to help protect those systems. You also need local admin on those systems in order to get access to the certificates. So there's kind of that secondary layer there too that helps protect you. But yeah, at the end of the day, if they're privileged systems and somebody gets privileged access to it, then they have persistent access.
Very important warning there. Absolutely fantastic. Any other questions, comments?
Maybe one thought on that, and would be great to have also your thoughts about that. So why is not Microsoft securing the certificate by the manager identity on the Arc server by storing a key in TPM? Because the exclusion to say you need to have a local admin permissions, the same approach can be used for primary refresh tokens, and there are some TPM protected keys, so they could include that one as a part for the authentication.
I like that.
It would be great to have feedback on that.
Feedback for those guys.
Yeah. Yep.
Okay, excellent. Then no more questions. Karl, it's a pleasure having you. Looking forward to the next time.
Thank you very much.
Thanks.